Hi everyone, I'm Jackie. So today I will continue my lesson of forces. So today's subtopic will be Newton's law. So today's lesson I will talk about Newton's first law and Newton's second law. Alright, so Newton's first law states that an object will remain at rest or continue in a straight line at constant speed. Means that you continue its motion, the object will continue its motion unless acted on by a resultant force. Alright, so this Newton's first law is also known as principle of inertia. Alright, let's see a daily example to demonstrate this law. Alright, so let's say you are riding on a bus. Alright, you stand on a moving bus. Then what if the bus suddenly emergency brake? What if the bus suddenly stop? What will happen? You will fall forward, right? Right? If you're not grabbing anything, grabbing any handle. Alright, so why will happen like this? Because based on the Newton first law inertia, you originally are moving, right? Because the bus is moving, so you originally are moving. Then if the bus suddenly stops, right? If the bus suddenly not moving, based on the Newton first law, you will not stop, alright? You will continue to move, right? So you will fall forward, right? So unless if you want to prevent this happen, you must grab something, right? So this grabbing something is like a resultant force to pull you back. All right. Let's see another example. Uh, Coin falls into cup when remove paper quickly. All right. Let's say you have this setup. All right, a coin on a paper, then a paper on a glass. All right. If you quickly pull the paper, what will happen? The coin will not move with the paper, right? Instead, it will fall into the cup. Alright, so this is also inertia, Newton's first law, because the coin originally is at rest, right? If you pull the paper fast enough, the effect of pulling paper will not affect the coin. So the coin will tend to stay at its original position, means at the uh, cup above. Then, but there is no paper anymore, right? So because of gravity, then the coin will fall into the cup. Alright, so this is also inertia. Alright, so Newton's second law states that when a resultant force acts on an object, it changes the velocity of the object. Alright, yeah, if you like push or pull the object, right, it will change the velocity, right? Alright, in another words, if we apply force on the object, push or pull or what, it will accelerate. Right? Recall that acceleration means that rate of change of velocity, right? So change the velocity also means that accelerate, right? So the heavier the object, the larger the force required to accelerate, right? Let's say you have a shopping cart, right? If the shopping cart is have many things very heavy, then you need larger force to push it, right? So this Newton's second law relates the acceleration, mass, and force together. So we have this definition. So Newton's second law's definition states that the acceleration of object is directly proportional to the net force. A is directly proportional to the F and inversely proportional to its mass. Right? So from the definition above, we can build this formula. A equals to F over M. So we rearrange, we get this. The F equals to M over MA, M times A. Alright, so F is force, unit is Newton, M is mass, unit is kg, and A is acceleration, unit is meter per second per second. Alright, so let's see how to solve this question. Alright, find the resultant force acting on this 5 kg object if this is accelerating at 3 meter per second to the right direction. Alright, so you use the formula F equals to MA. M is 5 kg, A is 3 meter per second. So you will get 15 Newton, alright, to the right. Alright, because the force will follow the direction of acceleration. So it's also to the right. Yeah, so this is today's lesson, talking about Newton's first law and Newton's second law. Right? Thank you.